Hi guys, you need to see this. New images from the Hubble telescope from December 12th and December 27th of interstellar object 3I Atlas, and we still don't know what it really is, and the mystery remains. And now we got more and more data coming in, and it's kind of really crazy. We need to talk about the wobbling jets of 3I Atlas again. The Hubble telescope reveals strange behavior. Let's dive into this, guys, because this object 3I Atlas keeps surprising us. So the new Hubble images show, they're beautiful, by the way, colorful. They show something we've never seen before in an interstellar visitor. These two jets of material and this dominant anti-tail sunward facing jets that is 10 times longer than it is wide, which is super strange, and it's also super long. Let's break this down, guys. I will explain the new findings so that it's simple and quickly to understand. The Hubble Space Telescope took pictures of 3I Atlas on December 12th and then again on December 27th. So brand new images. And the images were long exposures. That means 170 seconds exposure each, using a very sensitive camera. And then when the scientists processed these images with a special filter, they saw two narrow jets of material shooting off from the object. And one jet is the anti-tail, it's strong and it's pointing towards the sun, and the other one is weaker and points in a different direction. That would be the normal tail that normal comets should have. So let's talk about the brightness, because that is also a key point that was discovered. The brightness of these two jets changed between December 12th and December 27th. And that tells us, guys, and here that this is crucial, something is moving. And in my last video, I just explained to you that that dust is not typical for a comet, and that this cloud of dust is hiding the surface of 3I Atlas. That video will be in the end screen. And guys, please do me a favor. It doesn't cost you anything. Click an early like and click the hype button for my video. Thank you so much. Let's dive deeper into this. So the brightness, we need to bring back the wobbling jet. I've made a video about this earlier, but as I said, the change in the brightness tells us something is moving. So either the jets themselves are like wobbling, or the sources that create these jets are changing. Why does the wobble matter? Well, a wobbling jet suggests that the object's rotation axis isn't lined up with the jet direction. So as the object spins, the jet sweeps around. So, and if you follow the wobble pattern with images taken at different times, like we have it here, December 12th and 27th, you can start to track the rotation. And this is powerful information, guys. Very powerful. It tells us how the object 3I Atlas is spinning and how active its surface is. That's what we want to know, because we cannot see the surface. So in earlier observations, when it was first discovered on July 21st, 2025, the scientists already saw that the jet was pointing towards the sun, and it was very long and narrow, very anomalous, much longer than it was wide, 10 times to be precise. And that jet also already in July, when it was before perihelion, right? Before it reached closest point to the sun, it wobbled already a bit and implied that whatever was producing it was fixed near one rotational pole of 3I Atlas. So now the big question is, well, what is causing these two jets? There's two main ideas. First one, we have jets from opposite sides of the object. One jet comes from one side and the other comes from the opposite side. That pattern would mean a big change in how the object behaves after it passed perihelion, closest point to the sun. So heat on the sunward side could have carried inwards and energized material on the night side too. Well, you have to understand, let me find an object. This is my mouse. I am the sun, my face is the sun. Now, this is 3I Atlas. It has a sunward facing jet and it has a normal comet jet. So now it reaches perihelion, closest point to the sun. When it comes out of perihelion, the jet, the night shade jet, so to speak, is now facing towards the sun. This is now the new antitail. And this one is in the night angle, right? So the heat on the sunward side before perihelion could have carried inwards and energized material on the night side too, because we already saw both jets, right? Theory number 2, both jets are from the same side, but with different materials. So that super strong and long antitail could be big dust particles blown very, very far out. The weaker jet might be smaller dust or gas that's swept back by the solar wind. Solar wind is pushing particles off the object. And then those particles fall away faster and they shape the jet differently. We definitely need future spectroscopic data to find out what the two jets really are. We're waiting for these data. And then we need to conduct velocity measurements from advanced telescopes. They could hopefully tell us which of these explanations is correct. Going back to possibility 1 is that we have two jets launched from opposite sides. This could either be a natural explanation or a not so natural explanation. For a not natural comet, the heat conduction could transport the excess solar energy near perihelion. As I said, flip it from the day side to the night side and activate this weak jet on the night side, in addition to a stronger jet on the day side. If that was a technological object, the sunward jet, and that's interesting, right? It's strong and it's focused. It might be utilized for protection against the solar wind or coronal mass ejections or sunlight, because that antitail, usually the solar winds would push towards it and widen it. So it would be more a haze than a clear projected narrow jet. And then the secondary jet on the night side could be like headlights, could mitigate risk from outside obstacles that are coming ahead towards the object, right? So this is something that we still have to keep in mind because we still don't know what it is. So what changed between the two dates when the pictures were taken? The jets didn't look the same. They don't look the same. On December 12th to December 27th, they look different. So the strong antitail, the sunward jet, became brighter, while the weaker one dimmed a little bit. So was there an energy transfer? That pattern fits, guys, with a rotating and wobbling source, not just random variability, not just random, that's the word. So this wobble might even link to earlier brightness variation that was seen in other observations. And that periodic change had a cycle of about 16 hours. We talked about this. If you want more details about that wobble, which is highly interesting, I'll put that video in the end screen, and also my 3i Atlas playlist where I explain all the anomalies, guys. Really, really interesting. So if the nucleus of 3I Atlas is losing mass, that spin rate might change over time because it's losing mass, right? So now the scientists have to look at, and they are looking at, whether that is happening or not. And that's very exciting. We have seen comets from our own solar system with jets and tails that have shapes that change. But with interstellar objects, object 3I Atlas, guys, this is the first time that we have seen wobbling jets in an interstellar object captured by Hubble. So 3I Atlas is spinning, right? It's spinning. The object is spinning. 3I Atlas is not smooth. It has active spots on its surface. And these spots, they shoot out dust and gas like thrusters, these jets. And as 3I Atlas itself is rotating around its axis, the jet direction slowly sweeps around. And that sweep looks like a wobble in the new images. So Hubble saw the jet pointing slightly differently on December 12th and the 27th. That means the source of the jet moved, not randomly, because of rotation. Like, think about a garden sprinkler. We have the same water, but it sprays in different directions as it spins. So it's spinning. We don't have this lawn sprinkler. That was the wrong move. It's spinning. We have this rotating lawn sprinkler. That's the wobble. So this wobble, first time we see it, it's a chance to learn how material comes off a body that didn't originate in our solar system. The jets, they're telling us about rotation, surface activity, hopefully internal structure, and how solar heat affects this interstellar object and maybe all interstellar objects, right? So we will wait impatiently, at least I am, for new data that will tell us more. I hope you found this interesting, guys. Thank you for liking, for hyping. Would love to have you here. Subscribe and click the notification bell and check out the videos here in the end screen. A lot is going on. Thanks for watching, guys. Stay safe. Bye-bye.